9, 16, 25, 36, 49, 64, 81, 100, 121, 144. And so these are all perfect squares, right? And so you should be aware of these. When you see these, you should be able to identify their exponential form. 49 is 7 squared, 144 is 12 squared, 81 is 9 squared. You should be able to identify your perfect squares. Same is true with a couple perfect cubes. Okay, there's fewer of them that you need to be aware of, but you should be aware of 1 cubed, 2 cubed, 3 cubed, 4 cubed, those ones for sure. And then also 5 cubed and 6 cubed. Okay. Beyond that, you probably are fine, but these are the ones that you're going to see the most often. And you should be able to recognize that the cube root of 8 is 3, or the cube root of 216 is 6, the cube root of 64 is 4. Okay, those are ones that it will help you to know offhand. Now, the reason for this is kind of leads to this next property. And the next property is when you take a radical, it doesn't matter whether you apply the radical part or the power part to your base first. So the nth root of a to the m is the same as taking the nth root of a all to the power of m, or to take a to the m and then take that whole thing first and then take the nth root of that. Either of those, it doesn't matter which one applies first. The same is true in the rational power form of this. If you took a to the m over n, it's kind of like saying you can take a to the m and then take the whole thing to 1 over n, or you can take a to the 1 over n and then that whole thing to the power of n. And so those are properties that you should pay careful attention to, because you're going to be asked to simplify radicals and rational powers kind of in the following formats. Okay, so let's talk about how you would work to simplify these. You should be able to do any of these by hand, and the reason is always look to see, are your bases written as perfect powers, either perfect squares or perfect cubes? If they are, then you should be able to do it by hand. So what can we think of 27? 27 is a perfect cube, and so we could rewrite this in exponential form. What number cubed gives you 27? So 27 is 3 cubed. So what you could do is you could think of that as 3 cubed to the power of 2/3. And then what happens when you take a power to a power? You multiply. So this 3 and this third cancel, leaving 3 squared, which is just an answer 9. The other way that you could, again, think of this would be if you took and you applied this the index of 3 first. So what does the index of 3 represent? What radical? Index of 3 is a cube root. So what is the cube root? So if you kind of thought of this as the cube root of 27 squared, what is the cube root of 27? 3. 3 squared is 9. And so you can think of it in those forms. You can either leave it as a rational power, you can convert it into a radical, simplify it either way. Okay, what about 81 to the 3, negative 3/4? So 81 is a perfect power, right? It's a perfect square, so we could think of that as 9 squared to the negative 3/4. Well, we can also think of 9 as a perfect power. 9 is also a perfect square. We can think of it as 3 squared, then squared, and then that whole thing to the negative 3/4. And so once again, you have a power to a power. You simply multiply through. 2 times 2 is 4. This 4 cancels with this 4, leaving 3 to the minus third. What does a negative power do to your expression? It inverts it, so it takes that 3 and moves it to the base. Becomes 3 cubed in the denominator. And then the value for 3 cubed is 27. So you get 1 over 27 as your answer. All right, the final problem. The square root of 36 quantity cubed. Again, just go ahead. It doesn't matter which one you do first. So the square root of 36 can be simplified. Root 36 is just 6. And then 6 cubed is this last of the common powers that you should be aware of.